like to start off pretty much all of my talks by asking people to pretend that they're a robot. So pretend you're a robot, and you're placed in an environment that looks something like this. And I tell you that you have an objective. You're currently at point A, at ground, right over here, in this, hallway, classroom environment. And I tell you to get to some objective that navigates you to a goal that's roughly 100 meters away in the direction of the classroom. So how do you get there? Well, if the map is known, the navigation problem is relatively straightforward. You simply plan as if you would using Dijkstra's algorithm. You treat the black pixels as occupied, you treat the white pixels as free space, and you just navigate down the hallway, make a left at the bend, and continue on to the goal. The sort of research that I do involves thinking more about what happens when the map is not known, and about what you have to do in order to plan effectively through unknown space when much of the environment is just not known to you. Now, the standard thing to do is what I refer to as optimistic planning, where all unknown space is presumed to be unoccupied. The robot planning using such a strategy plans a trajectory that looks something like this. But it makes an early left turn into what you or I might recognize is a dead end. It's a classroom, it doesn't have another door at the back, it has this little supply closet that inevitably the robot is going to find itself navigating towards, and then it's not going to be able to navigate towards the goal without leaving the classroom and backtracking on itself. So optimistic planning is kind of frustrating because it results in suboptimal planning. Robots tend to navigate themselves in unfavorable directions and enter many classrooms, offices, closets, things that people tend to know are, let's say, obvious dead ends. Humans know to follow hallways because hallways are specifically designed with the intention of connecting faraway regions of space. So if we want the robot to replicate behavior like humans do, how do we do this? How do we encourage a robot to plan well? Well, the robot needs to think more critically about what unknown space might look like. In this case, it might plan many, many different trajectories based on what it thinks might be in the unknown space: occupied, unoccupied grid cells, walls, boundaries, dead ends, etc. And it might plan many different trajectories and imagine, in addition to that, how its plan might change once it actually enters unknown space and reveals more of the environment. Now, the robot is trying to ask itself which of these many trajectories is best. A very difficult question to answer in general because it requires that the robot make predictions about all of unknown space. But as a human, you probably are thinking to yourself, well, I don't plan this way. Instead, the decision that I indeed presented to you at the beginning of this brief talk is about, well, whether you enter the classroom or whether you continue down the hallway. And in addition to that, you probably don't care as much about the specifics of precisely how you would move once you get there, because you know that the world will change, your plan will change once you reveal more of unknown space. And I certainly care more about the big picture. Can I make progress towards my goal by exploring each of these different regions of space? So I've just described briefly a change in representation, a shift from thinking about trajectories to reasoning about what I refer to as high-level or topological actions. Now, this shift has a number of advantages. First of all, there are now only two actions that we need to decide between versus the basically infinite number of possible trajectories that exist in a continuous unknown environment. And now we can ask much more useful, targeted questions about the unknown environment. Rather than asking which trajectory is best, the robot can instead ask, for each of these high-level actions, which way is more likely to lead me to the goal that I seek? Now, in my work, I have used machine learning to fill this gap. We take in a bunch of images, we can make predictions based on our experience that the hallway is indeed more likely to reach a faraway goal, and encourage the robot to similarly avoid the classroom. The results in my work show the effectiveness of this idea. This is the same agent, but now using our new planner and using machine learning to predominantly avoid many of these dead ends that foiled our naive planner. In my work, changing the way that a robotic agent thinks about how it will interact with the world, and equally importantly, what the outcomes of its actions will be, allows us to make more effective and intelligent decisions, even when much of the world is not known to us. And so my work is about the way that we think and reason in new and unfamiliar places. Robots will need new representations like the one that I just showed you if they are to continue to learn and plan effectively in the real world. How we represent the world around us is critical to our ability to effectively interact with it. And my research mission is the development of new such representations so that we can make robots that plan, navigate, and just behave more intelligently as humans do in places that they've never been before. So briefly, some of the projects that I'm potentially interested for any students in the room that are interested in talking to me is I want robots to know when their judgments are maybe poor. For example, in similar environments, like the ones that they have seen at training time, robots should justifiably trust their experience. But when placed in an environment that is somehow fundamentally different to any that it has seen before, the robot should have a mechanism for questioning whether its learning is helping it or actually hurting it, and decide to use a different planning strategy online as it navigates. In addition, I want robots that humans feel comfortable sharing the world with. And in addition, I think one key component of that is robots that can reasonably explain and justify their decisions to humans. A simple example of this idea is to ask the robot, why did you decide to avoid the classroom? And for the robot to not just say, well, I thought the hallway was more likely to lead to the goal, but justify why it was that it thought that the classroom was less likely to lead to the goal. So if any of this is interest to you, I realize I'm slightly over time, feel free to reach out to me. I'll post my email in the chat. I'm definitely looking for some interested students who want to work at the intersection of AI and machine learning and robotics. So thank you very much.